Today we're going to talk about a security information and event management system, and we'll talk about the concepts of it, some of the benefits of using one, a little bit about optimization, and the capabilities of a SIEM. We have 3 learning objectives today, and they really are to explore and understand the key terms of what a SIEM is, to explore the roles of a SIEM on a network, and to understand the role of a SIEM in a modern security operations center. So let's get started. System or security information event management system is really a data aggregator, search, and reporting system. It really takes a lot of information from your network environment and consolidates that and makes that data available into a format that is easily accessible and easily readable by a human. And it categorizes that data so it's all laid out at your fingertips to make things easier to understand. There really are here are some key terms around what we're going to talk about today as far as a SIEM goes. So we're talking about log collection, normalization, correlation, aggregation, and then reporting. And these are all important when you consider them in the context of what a SIEM is. A SIEM basically collects logs and other security-related documentation for analysis. And the logs, if you don't know, are really information that happens on a device like a firewall or a web proxy or any kind of device that is providing network security or an application. So any application typically has a log file that will tell what exactly happened in the log. And the core function of a SIEM is to manage your network security by monitoring network flows and events. Events are things that happen within an application or on a hardware device. And then the SIEM consolidates those log events and the network flow data, and it really pulls this from thousands of different devices, things like endpoints, applications, network hardware, anything that is touching the network. And then it uses advanced analytics to normalize and correlate that data and helps identify security offenses that might require investigation. A SIEM really takes 2 different approaches. It can be a rules-based approach or employ a statistical correlation to establish relationships between log entries. And then it will capture that log event and network flow data in near real time and apply analytics to that to reveal security offenses in the network. There are several different ways that a SIEM can be deployed or consumed, if you will. It can be on-prem through either software or appliances in your own data center. It can be in a cloud environment, so I go to a web browser and log into a hosted environment, or it can be provided in what is called an MSSP, a Managed Security Services Provider, where they would host it for a specific company and allow you to log on similar to a cloud environment. So let's talk about events and flows. Events are typically a log of a specific action. So things like a user login or a firewall permit or denial, it occurs at a specific time and the event is logged at that time. And then that device or application would push that event to the SIEM, and the SIEM would process that in either this is normal behavior or this is abnormal behavior. Flows are a record of network activity between 2 hosts, and those hosts, or that connectivity, I should say, can last for a few seconds or days depending on the activity within the session. So if you're transferring a large file, it will last for longer than if it's just a very short burst of communication like an instant message or an email being sent. The network activity, when we say hosts, it could be a PC on your network that's talking to a hosted machine like you're on an internet page, or if you're transferring a file up to a cloud service like a Dropbox or Box, anything like that is considered a network communication between hosts. Another example might be downloading multiple files, images, videos, and that might last for 5 or 10 seconds, or if you're watching a Netflix movie, that might last for a few hours. And those are all network sessions, and those flows are records that are captured of the amount of time and what was transferred between the 2 hosts. When we talk about data collection in the context of a SIEM, we're talking about the process of collecting those flows and logs from different sources and putting them into a common repository or database that the SIEM will analyze in order to make determinations if something is normal or if it's anomalous or abnormal. And it can be performed by sending data directly into the SIEM or an external device that can collect that log data from a source and aggregate it and then move it on demand at a schedule or whatever the SIEM operator wants them to. Now, to be frank, the SIEM data is going to be much more valuable if it's real time. So if the data is pulled directly from the device at the time it happens to the SIEM, you get better information and you get much faster information so that analysis can occur in real time and provide the SOC analyst with data that is needed to determine if behavior or things going on are anomalous. Things to consider as far as how much data to pull in and how often to do that are really governed by a couple of different things. The amount of CPU that has been assigned to the SIEM application, or if you're using an appliance, to that SIEM appliance. Same with memory and storage capacity. Of course, the license associated with your SIEM is going to make a difference as well. Most SIEMs are licensed in the concept of what we call EPS, events per second, and FPM, flows per minute. So the number of network flows per minute and the number of events per second is how most SIEM providers or systems license their SIEM. And then, of course, the number of sources that are being pulled into the SIEM are going to be important as well. So the more sources you bring in, the more EPS you're going to consume, and then more flows you're going to consume as well. So those are all factors to consider when you're sizing how many resources to assign to your SIEM. Let's talk about normalization. Normalization is the process that takes raw data and puts it into a format that can be read by a SOC analyst. So things like the IP address, the Q identification, any data that is needed to provide information that is usable. It involves parsing that raw event data and preparing the data to display so it makes it more readable, and it results or allows for predictable and consistent storage of all the records. So regardless of what the system that the data is being pulled from, it gets normalized into a format that is readable. So I can see things like IP address, I can see things like machine name if that's available, username if that's available. It gives me more information about what's going on in the environment. The other thing we should talk about is licensing and license throttling. So most SIEMs, as I mentioned before, will be licensed by the number of EPS and the number of flows. And license throttling will monitor the number of incoming events and manage that input queue into the EPS or flow licensing. So if I go over that, those events that are coming in might be throttled or might be queued until I go under my license threshold, or in the event of too many at one time, they may actually be dropped and put directly into storage or just dropped altogether. It all depends on the system and how it's monitored. So those are all considerations to think about when you look at the number of sources you bring in. Another concept that we talk about within SIEM is what we call coalescing. And then coalescing events are parsed and then coalesced based on common attributes across events. QRadar is IBM's SIEM product. So the examples we're going to use in this presentation are all based on QRadar. An event coalescing, it occurs after 3 events have been found with matching properties within a 10-second period. So if I find 3 events coming from the same machine, I'm going to coalesce those into a single event with those 3 different properties into the same event essentially. And it's processed in order to normalize it and really to keep the system from displaying too much information that makes it more difficult to sort and to analyze that information. When we talk about coalescing and how we combine those, there's 5 properties that are evaluated. So if the 5 properties match and we have 3 events within a 10-second period, they will all go to the same machine in the same event. And that's the Q identification or QID, the source IP, the destination IP, the destination port, and the username. Those are all things that go into what we call event coalescing within QRadar. And then coalescing to get into more detail, those events are parsed, and when we find common attributes across those events, and we normalize that data into those fields. We'll get more data than just those 5 things that we show on the screen, but those are the attributes that go into what makes up coalescing. So when we have 3 events in a 10-second period, all 5 of those things match: the QID, the source IP, the destination IP, the destination port, and the username. Those are all going to be coalesced into a single event for the SOC analyst to look at and to be able to make sense of. And then let's talk about really what offenses are. So offenses are anomalous behavior that the system sees as, hey, this is something that doesn't make sense, or something that is outside of the norm, so you should probably take a look at it. And those data points can come from lots of different sources. So things like security devices, security devices, servers and mainframes, network activity, data activity if I'm accessing a database, application activity if I'm using a chat application or Microsoft Office 365, configuration info on a system, vulnerability and threat data, which is very important to a SIEM, and then users and identity. So one of the things that might be anomalous is a user logs in from multiple locations within a very short period of time. You might see someone's user ID trying to be logged in from the United States, then from India, and then from Romania in a few seconds or a few minutes. That's obviously anomalous behavior because that couldn't happen logically. So those are things that might turn into what we would call an offense. And all those things are put into event correlation, so things like logs and flows and IP and your geolocation, as I mentioned in the example before. And then that activity is baseline to look for anomalies, and then those will be put into an offense. And then offense is what the SOC analyst will look at to see if I need to do some further investigation in this. And a good SIEM will try to tune out the noise of false positives or anomalous behavior that really isn't an issue, and provide what we call a true offense, or something that can be and should be investigated. The challenge many organizations have when leveraging a SIEM is you get all this data in, and those filter into too many offenses that are not true offenses, and then they can't be investigated in a timely fashion. And so unfortunately, the SIEM just becomes noise in the environment. So the whole goal of a SIEM is to be tuned well enough that I can look at all the data that's coming in and tune it effectively so that I'm only looking at offenses that really need to be investigated, that are true offenses. So when you're looking at deploying a SIEM, there are really a couple things that you want to consider, and that is compliance. Are there some mandates that you need to measure against? Things like GDPR, or many regulations in the United States like HIPAA, the Health and Information Portability and Privacy Act, PCI, which is what credit card processors measure against. So there are all kinds of regulations and compliance metrics that need to be measured against, and a SIEM can help do that. There's also a cost-benefit analysis, of course. Anytime you invest in a new technology, what is the benefit you're getting? What business value does it provide to the business? And then, of course, the cybersecurity aspect. As technology becomes more prevalent in our lives, there are more things that bad actors that can try to cause issues within the environment for monetary gain or for other nefarious purposes. So cybersecurity is also an important consideration. We want to protect the data within our environment, obviously. I'm going to give you a brief example of a QRadar deployment. And this is really very similar for any SIEM, whether it be IBM's QRadar or any of the other SIEMs on the market. So when you look at the deployment scenario, what you will typically have is flows coming in from a network source like a span or tap or a router, and that gets translated into what we call Q flow, which is the format that QRadar can read, and then that's sent to a flow processor. And these can all be either hardware appliances or they can be software. And then that is brought into the console for the SOC analyst to look at. The event and log sources are done exactly the same way. They go to an event collector and then an event processor and into the console. In smaller environments, all of these appliances can be a single appliance. So a small implementation may only have one appliance that is doing the work of all the things that you see here. Let's go into a little bit more detail about the event collector and the event processor. The event collector collects the events from local and remote log sources and normalizes that log source events to a format that QRadar can read. Now, an event collector is really used in remote locations. So if you have multiple locations or multiple data centers, you may have an event collector in each of those data centers that feeds into an event processor. And the event processor processes those events, as its name implies, that come from one or more event collectors. And then those events are processed using what we call our custom rules engine. Our rules are how we determine if behavior is anomalous, essentially. So the event is processed, it goes through the custom rules engine. Someone sees, oh yeah, this is behavior that that doesn't look right, so we're gonna flag it as an offense, and that's what happens on the event processor. Flows are done in a similar fashion. So the flow collector collects flow data from packets, and those are collected from monitor reports like a span or a tap or sessions like that. And then they can also be collected from sources like NetFlow or SFlow or JFlow, and then it's converted into the QRadar format, which is QFlow, and then it's sent to the event flow processor for processing. And as with an event collector, a flow collector would be put in a remote data center. So you might have multiple flow collectors depending on your data center architecture. You may have a data center in one city and another one in another city, and so you could put event and flow collectors in each of those data centers to then feed into a flow processor in your main data center. It just depends on how large the organization is, how many sources they have, and their geographic distribution when we look at sizing a SIEM. The flow processor then deduplicates those flows. If those sources are coming into different flow collectors, but it's the same source, the flow processor will dedupe that, and then it will do things like asymmetric recombination, which is combining the two sides of the flow when the data is provided asymmetrically. So it recognizes flows from each side and then combines them into one record. However, you may not always get both sides of the flow. You may only get that I went out to a specific network host and not the information from back in. But when you get it from both, we can recognize those two different flows and combine them into one. There may be some reasons why you want to. We talked earlier about an all-in-one deployment, which is a single appliance that would be used for in this case, QRadar deployment. So if your data collection requirements exceed the collection capability of your all-in-one all-in-one appliance, if you want to collect events and flows from different locations and you're not getting good throughput directly to the all-in-one appliance. If you're monitoring packet-based flow sources, you might want to add a flow collector. And as your deployment grows, your workload may in fact exceed what you can do with an all-in-one appliance. So those are factors to consider, as well as the search speed. So if you have more analysts than can do concurrent searches that the all-in-one appliance can handle, that would lead one to a more distributed architecture as opposed to doing everything on a single appliance, as well as things like retention period. Many organizations have a mandate for how long they need to retain this data. So if the storage requirements for your data retention periods get too large for a single appliance, that may require a deployment of multiple appliances. And as your team grows, you might require better search performance. So those are all things that will lead to moving from a single appliance to a multi-appliance deployment. Here's how what we talk about a SIEM and how it fits into the concept of a security operations center or SOC. So the security operations really, as you would expect, is the people, the process, and the technology. And of course, the SIEM fits into the technology piece. So that would be things like other things in the technology piece, endpoints, your flow, your network monitoring, any incident forensics you're going to do, and threat intel. And then of course the people are probably the most important component of the SOC, because they are really what takes the data that the SIEM is providing and provides intelligence around that to determine if an event or offense needs to be investigated more with more detail. So your formal training, your internal training, of course on-the-job experience, nothing can compete with that. And if you have vendor-specific training for the tools that you leverage within the environment. And then the process that goes into your SOC. So what is the process for what you do when an event turns into an offense and when that offense needs to be investigated? And it really is a closed loop kind of thing, from preparation to identification. How do we contain it, get rid of it, recover from it, and then lessons learned, and that goes back into the preparation step. So the process is a very important part of the SOC component as well. Here's how we talk about SOC data collection for improved incident handling. So we want to talk about the visibility, because we're centralizing all those data sources into a SIEM or security monitoring system, and by getting all the information from things like network traffic, your system logs, your endpoint data, your external threat intel feeds, and your events all go into the SIEM. And we want to make sure that everything that we have in the environment is visible. So we really want to feed as many data sources as we can into the SIEM so that we have visibility across the entire environment. Obviously, there are things like licensing considerations and budget and those kind of things that will dictate how many sources we can bring into the SIEM. But when we have determined all of the sources that we want to bring into our SIEM, and we look at the monitoring system or the SIEM for the analysis, we want the SIEM to provide as much data and as much intelligence around that as possible, so that when the security analyst actually analyzes it, they're filtering out all the noise and really only looking at the things that should be and need to be investigated. And then the action around that. So once we have our findings and we determine what the correct investigation process is, and then what the correct remediation process is, whether it be patching, modifying the firewall rules, quarantining a system to do further investigation, or even potential re-imaging, the action is what you're going to do to take care of the issue that was found during the analysis and investigation. So I hope over the last few minutes we've given you some introduction to what a SIEM is and what it can do to help protect the environment. Hi there. This is Jude Lancaster, and today we're going to talk about different SIEM solutions in the marketplace, all the different vendors that are out there, and focus on a few of them. Learning topics of this video are, as I mentioned, to explore the different SIEM vendors and what their different components are. So let's get started. The security information and event management market is defined by customers' need to analyze security event data in real time, and that really supports the early detection of attacks and breaches. SIEM solutions collect, store, investigate, and support mitigation and report on security data for incident response, forensics, and regulatory compliance. We'll talk about the vendors mostly included in the Magic Quadrants, and they have products designed for this purpose, and we actively market and sell them to security buying customers in all ranges of industries. This is Gartner's Magic Quadrant, which many of you might be familiar with. Obviously, up and to the right is the preferred placement for a technology. You'll see IBM and Splunk very high there, as well as Exabeam, Logarithm, and Rapid7, and a few other technologies. And then you have some more point solutions that we really don't see in the marketplace as much as those in the Magic Quadrant. We're going to focus on IBM QRadar, Splunk, Exabeam, and Logarithm today. So let's talk about deployments for a moment. Gartner defines a small deployment as one with around 300 log sources, so 300 different devices or software that are providing data into the SIEM, and about 1,500 EPS. EPS is events per second, which is how SIEM solutions are typically measured and licensed. A medium deployment is about 1,000 log sources and 7,000 EPS, and a large deployment would be about 1,000 log sources and then about 15,000 EPS. This slide doesn't talk about flows, which are the communication between devices on a network, but flows are also very important, and not every SIEM solution collects flows, but they really are an important facet of the overall security policy. They tell what communication is happening between an endpoint on your network and an endpoint somewhere else, such as a web page or a server or something like that. So let's talk about some concepts. SIEM is the security information and management tool, and it provides that real-time analysis of alerts, which are generated by network hardware as well as applications. A rule is a procedure that attempts to correlate these events into a report or an incident so that you can see what's going on in the environment. A rule threshold is the point which the rule is triggered, and then that correlation event is generated. Event threshold is the number of times the event must occur before triggering the rule threshold. A rule action is a procedure that occurs when all rule conditions and threshold settings have been met. So what's going to happen when those things occur. And then a trend is a resource that defines how and over what time data will be aggregated and evaluated for trends. So a trend executes a specified query on a defined schedule and time duration. An event is the actual log of a specific user action, such as a login, a firewall permit. It occurs at a specific time, and the event is logged at that time. As I mentioned before, flows, which are equally as important as events, is a record of network activity, and it can last for seconds, minutes, hours, or even days, depending on the activity within the session. So as an example, might be sending an email, might be a flow that lasts for a few seconds, whereas downloading a large file might last for hours or even days. Data collection is the process of collecting flows and logs from different sources, and that typically goes into some kind of common repository like a database built into the SIEM. Normalization is what happens when raw events are turned into a format that has user-readable fields such as IP address, machine name, things like that, and that helps the user look at those raw events. Licensing and license throttling monitors the number of events and flows to the system to manage your licensing. And most SIEMs are licensed in this way, either events per second and flows per second, or a combination of the two. Coalescing combines those events based on common attributes. So if we see several actions from one endpoint in a short period of time, those will typically be combined into a single event. So the first technology we're going to talk about is IBM QRadar. IBM QRadar came out in 2005. It originally came out as Q1 Labs, and it really started a little bit differently than most SIEMs because it started with flows. So QRadar looked at network behavior anomalies, and its NBAD platform from QRadar, Network Behavior Anomaly Detection Platform, and then was purchased by IBM in 2012 and really has been the pillar of IBM's security business since that time. It's proprietary based on aerial data store and a proprietary aerial query language. So it uses an aerial database to store data and events and flows that come into the system. It does log correlation, network forensics, leverages intelligence feeds, vulnerability management, and then it has a risk management component as well. There are several components to QRadar. These are not all of them, but are probably the most popular ones. Vulnerability Manager discovers and senses network devices and applications, and then pulls in security vulnerabilities and provides context around that so you can prioritize remediation of those particular devices. It's part of the IBM Security QRadar platform, is an add-on for that, and it allows you to do vulnerability scans of machines and devices on your network. User behavior analytics, which is becoming more and more popular because users, whether through malicious activity or just through mistakes or incidental activity, are really the main place where breaches and risks occur. And QRadar User Behavior Analytics is an add-on, but it's a free add-on for QRadar that analyzes user activity and can detect insider malicious behavior, can detect things like whether users' credentials have been compromised, and you can prioritize users as far as their risk activity. So it's something that's very, very useful for QRadar customers. And then the QRadar Network Insights tool leverages flow data, which is really a differentiator between QRadar and other SIEMs on the market. Most other SIEMs do not bring flow data into their SIEM natively. Some will take flow data and then pull that in as an event, but that really doesn't give you the full picture of what's actually going on. Network Insights can pull in network data real time, and really give insight into what's happening in the environment. Because the first thing that a hacker or bad actor will do is turn off logging. So that really hides the information that is coming into the SIEM if logs are turned off. However, the network doesn't lie. You can't turn off information that's going on in the network, and that's why flows are so important, because you can detect things like phishing emails, malware, data exfiltration, which is really important, lateral movement within the environment, and other application abuses and compliance gaps. So flow data is really important, and network insights around that is important. Well, let's talk next about ArcSight, and there's a SIEM solution that does event correlation and security analytics. It is comprised of several different components: ArcSight Manager, its core engine, which is the correlation optimized retention and retrieval engine. It has a console to view all this data together, and then the command center, and then it also leverages APIs from which you can integrate other solutions into the ArcSight ESM. As with other SIEMs, it allows you to monitor events in real time and correlate those events to be easier viewed by the solution. Splunk has been around for about 10 years now and didn't really start out as a SIEM, but has gained a lot of popularity in this space. Splunk's goal is to make machine data accessible, usable, and valuable to everyone. So the whole goal is to take that information and from multiple different sources and combine it into a single data store, if you will, so that that data can be viewed in a single pane of glass. And that's Splunk's operational intelligence, and that's the unique value proposition that they bring. They also have several free technology add-ons that can provide some additional value. The Distributed Management Console pulls all the Splunk architecture management together in a single set of dashboards. As I mentioned before, Splunk didn't start out as a SIEM, but has really broadened its offerings into a very robust SIEM solution. here's a kind of a representation of Splunk's services, or Splunk's architecture, I should say. So it has a data collection layer from that are forwarding things like syslog, potentially API, scripts, things across the wire, etc. And then it provides that into a data indexing layer, which then goes into the data presentation layer, which is what the web browser will present to the end user through its visibility. And then finally, let's talk about Logarithm, and they also have a robust security intelligence platform also in the Gartner Magic Quadrant. It supports centralized management of a Logarithm implementation. That's what Platform Manager does. Has a data processor which performs log collection and management. So that would be the item that, or the piece of hardware that actually pulls in the collection of the different logs. Your data indexer indexes your data and metadata, and it has an AI engine, an artificial intelligence engine that provides the correlation and analysis capabilities. So that's what does all the correlation of log events, pulls it all together, and gives you some information around rules and analysis. They offer also an all-in-one for smaller implementations that combines all of those solutions into a single appliance. They can also do some network monitoring, which does deep analysis of network traffic content. So allows for information around the network itself. And then the data collector collects log data from remote systems and then prepares it for transfer to the centralized Logarithm platform implementation. So if you have different locations, you can put a data collector there, and that will forward that data onto the main Logarithm implementation. Hi there. This is Jude Lancaster. Today I'm going to go through a couple of charts on QRadar and, just as an industry example, the features that the QRadar SIEM provides. Really the only learning objective we have in this is to get a better understanding of QRadar from a security analyst point of view. QRadar, IBM Security Intelligence Platform, is really designed to solve the security challenges like detecting advanced threats, detecting insider threats, securing cloud resources. As more companies move to the cloud and move their workloads to the cloud, we find that it is much more important to protect that data and keep those workloads secure on public clouds, private clouds, as well as hybrid clouds. And QRadar can also help customers protect their critical data, such as databases, any customer data where it resides, so protecting a company's data of their own customers, as well as patient data, government data, pretty much any data, whether it resides in the cloud, on-prem, regardless of where it is. QRadar can help protect that and effectively respond to incidents when they are detected by QRadar. We can also help prioritize and manage the risk, and in many cases, and importantly, prove compliance. Many organizations have compliance mandates that they have to adhere to. In the United States, we have several. PCI, which is the payment card industry, for people who accept credit cards, HIPAA, which is the Health Information Portability and Privacy Act, which protects patient data, and there are other regional agreements as well. And in Europe, GDPR has become very, very important, and we see a lot of customers need to have mandates. So QRadar can help protect that data as well. It really also allows customers to become proactive as opposed to reacting to threats. So QRadar can help customers hunt threats, respond more quickly, and then continuously improve the security posture of the organization by providing metrics and information about threats in the environment. One of the nice things that QRadar also does is we have a tremendous amount now, as I talk today, more than 220 applications that can be added to QRadar as part of the Security App Exchange. So we have applications from many of our partners, as well as IBM-built applications that improve the functionality and usability of QRadar. One of the applications that we'll go into a lot more detail is our user behavior analytics app and we're going to do that in another presentation. But there are more, as I said, there are more than 220 applications, the majority of them free, which help provide additional insight as well as functionality to QRadar. And they really provide seamless integration that augments the QRadar platform. They're built specifically for QRadar and do a great job of bringing in additional information depending on what hardware you may use or what networking equipment. There are lots of integrations we have in order to provide that information. One of the things that we also want to do with QRadar is automate the intelligence that goes into or that is being provided to the SOC analyst by providing automated analytics. So when we talk about automation and we talk about intelligence or AI, we're really talking about our Watson platform. And Watson scours the internet for security information, both in structured data and unstructured data, and then provides that to QRadar customers when they need to investigate a threat. So if I find something in my QRadar console that looks anomalous, I can ask Watson to give me more detail about it, and then we'll go out to places like the X-Force Exchange, which is the third largest web crawler on the internet after Google and now. But as the third largest web crawler, the X-Force Exchange, when paired with Watson, will automate the identification and evaluation of the severity of threats that are identified by QRadar. So it provides a great amount of resources when you're looking at doing investigations around threats that have been detected. And because we're able to do things like protect cloud assets and cloud data, we can see the entire environment. So it doesn't matter if the assets that we're looking at are in the cloud. It doesn't matter if they're in your own data center. It doesn't matter if it's an employee working on a VPN. Those are all assets that can be identified and protected by QRadar. So QRadar can be digested by customers in many different ways. It can be done in your own data center as hardware appliances or as software to run in your own data center. It can be consumed as a service from IBM or from some of our partners in a SaaS model, or you can even have someone manage it for you where they do all the work and you just consume the content. It can also be run on a public cloud such as AWS, Azure, IBM's cloud, or the Google cloud, or it can be consumed in a hybrid model. So part of the solution being on-prem, maybe some parts of the solution being SaaS or infrastructure as a service. So hopefully we've given you a little bit of a more detail around QRadar and what features it has. Let's talk about how UBA and a SIEM can help and what things they can actually monitor and protect. And you'll see UBA written a couple of different ways. You'll see it written as UBA, User Behavior Analytics, or UEBA, User and Entity Behavior Analytics. So an entity could be a machine, an entity could be an account that is not an actual user. So those terms are essentially the same thing. We're monitoring the same thing when we talk about UBA or User and Entity Behavior Analytics. And really it all fundamentally comes down to the SIEM, because that's where all this data is brought into, and then UBA will look at that data in a different way and evaluate risks based on users. And so we're getting things from threat intel sources like IBM's X-Force, your networking equipment or network infrastructure, so things like firewalls, switches, routers, those kind of things. Systems that are in the cloud. Your identity and access systems become very important with UBA because that is tracking who has privileged account access and what they're logging into. Of course, data is very important. You know, things like databases and any of your data that is important, customer data, those kind of things. Your applications, homegrown applications, or applications where you're storing your data. And then, of course, mobile devices, as we see a prevalence for people working from home now. As I record this, we're in the middle of the COVID-19 pandemic, so most people who can are working from home in the United States, and that poses even a more fundamental problem around user behavior. And then, of course, your endpoint, so the actual machine that someone is logging into to access corporate resources. And the security ecosystem that brings all these log sources and flow sources together in the SIEM are really what make up our security ecosystem. That's the fundamental part of the security ecosystem to help protect organizations. So there really are some advantages of an integrated UBA solution, and we'll talk a little bit specifically about IBM QRadar UBA, or User Behavior Analytics. It gives you complete visibility across the endpoint, your network, and your cloud infrastructure with both log sources and flow data. The first thing that malicious actors will do when they get into a corporate resource is turn off logging. And if logging is turned off, you can't see anything and you're pretty much blind. However, network data does not lie. So if I can see the infiltration from a network perspective, I see that the malicious actor's IP address was able to gain access to an IP address in my organization. I'm able to see what's going on from a network perspective, and depending on what type of solution I have, I may be able to even be able to see what kind of communication is happening between those devices, whether it's a data exfiltration, whether it's a command and control, but the nut of it is that network data doesn't lie. QRadar User Behavior Analytics gives you faster time to insights and frees up valuable resources for other investigations as well. Provides analytic models that leverage the security operations platform, and works because it is integrated with QRadar. It works with the same workflow and same pane of glass that QRadar provides, as well as also leveraging artificial intelligence from QRadar Advisor. And it also can help with third-party analytics models that may be using existing insider threat use cases that you've already implemented. So it can integrate with other tools and other use case models that you may have implemented in your organization. So this is a screenshot of IBM QRadar User Behavior Analytics, and there really are three use cases we're going to talk about: compromised or stolen credentials, careless or malicious insiders, and we really won't distinguish between those because essentially the activity may be the same, even though the motivations are different. And then a malware takeover of user accounts. Within QRadar User Behavior Analytics, we have more than 160 rules that are and machine learning driven use cases that address those three major inside threat vectors that I mentioned. So here's how QRadar detects compromised credentials, and you'll see that we have mapped this to the MITRE ATT&CK framework. So this may look familiar to many of you, and here are some of the vectors that we're looking at. So things like phishing, download. So if someone is forced to go, or it clicks on a link and goes to a URL and that downloads some weaponized malware, and the use cases around that are accessing a risky IP and then getting those malware. And then you'll see that the third row shows some of the data sources that will help UBA figure those use cases and give you information around those. So when you look at phishing, it's things like your firewall and your web gateway. If you're looking at command and control, it's potentially the tactic is an outbound communication with a command and control server. And then you can look at these at your leisure, but these are things that QRadar UBA can help protect organizations from across the line, from phishing all the way to data exfiltration. Malicious behavior, unfortunately, is very hard to track because there are many different types of malicious behavior. So it could be someone with VPN access that has someone else's credentials, so they're using someone else's VPN certificate, abnormal login times, so logins outside of normal hours or from different location. You know, one of the things that we'll track is someone logging in, say, from one state and then a state 1,000 miles away within a very short amount of time that would make it geographically impossible for that to occur. Abnormal file access and download, so changes in download behavior, things like activity and frequency change and potential escalation of privileges are all things that could be an issue and bear investigation and would be alerted within UBA. And then also excessive printing that does data exfiltration or a large transfer of files to a particular print server for exfiltration later. Secondly, we'll look at an abnormal drop in file activity, abnormal drop in email activity, so like I said before, user access at unusual time, an abnormal drop in web activity, or visits to job search sites are all things that we may want to track. And then I talked about it before, abnormal login time, abnormal file access and download. We can also track whether USB devices have been inserted and what types of data is being saved to those USB devices from writing to the USB from things like endpoint logs, print server logs, or DLP solutions, data loss prevention solutions. User behavior analytics does require some maturity in order for it to be effective. You're not going to buy a SIEM, install it, and then start using UBA right away and get data from it. It really is a curve of, and our more mature organizations are ones that are able to successfully leverage UBA. You know, you have to get your SIEM set up and tuned correctly. And so you need to get your log sources input correctly and make sure that they're parsing correctly in the SIEM. Your LDAP set up that does those reference maps around users and different parts of the organization. User ID coalescing. So oftentimes the same user may have multiple IDs. So we need to make sure that we're tracking those things and make sure that you're aligning with your business needs. And then you need to configure and tune the system so that you're getting the correct data within the SIEM and making sure that you're not getting false positives and those kind of things. So when you look at leveraging UBA, whether it's IBM QRadar UBA or any UBA solution, the steps are to focus on your account and the access that people have, expand to your user views with network and session data, and then build and compare to the peer group, so other people within the organization that have a similar job. And those are all things that can be tracked with machine learning within QRadar. And then you'll look at some outcomes from the analytics that you are gathering, or the data you are gathering, I should say. So things like account anomalies, access deviations, looking at abnormal user behavior. So if someone may download 10 megs of data a month and all of a sudden they're downloading gigs and gigs of data, that might be something we want to obviously investigate. And then detect users deviating from their normal behavior, which I mentioned, or from people within the peer group, are all things that are anomalous behavior that can be tracked with QRadar and would need to be investigated. UBA, and specifically QRadar UBA, really does deliver additional value to your security operations center. It makes your analysts more effective because they can help detect known as well as unknown threats, and it helps reduce your time to detection and identify activities that need to be investigated more quickly. Makes your analysts more effective and efficient, and provide a pretty positive ROI because every QRadar customer is eligible, or I should say is able to use UBA. It's a free add-on for QRadar. You just download it from the IBM App Exchange, you install it on your system, and you start enabling the rules that are important to you and your organization, and you'll get data very quickly. When you turn on machine learning, you'll get even better insights because it will track the kind of behavior that particular users and groups do, and then will help identify anomalous behavior if they deviate from their normal behavior. It's quick to deploy and configure. As I mentioned, it's just an app that is downloaded, and it's really easy to tune. So the time to value is very short as well. Thanks for your attention. That's what I wanted to cover today.
In this video, you will learn to describe artificial intelligence, or AI, and its benefits to you as an analyst. Whether you're part of a security team of 2 or 100, your goals are to ensure the business thrives, and that means protecting systems and data to stay compliant, stopping threats, and staying ahead of cybercrime. But the pressures plaguing the modern SOC today make it difficult for you to achieve your goals. Let's take a closer look at the 5 challenges most SOCs are facing today. Organizations are facing more challenges than ever to achieve their business goals. You might find yourself saying, "There's so much information, it's impossible to find what's useful and connected. My workload is overwhelming and repetitive, and I don't know where to begin. I'm new to the industry, and it'll take me time to develop my skills. I don't know where to focus my time on, and I'm facing increased scrutiny from executive leadership's clients, employees, investors, and regulators." CISOs are adopting more point solutions than ever before to stop new evolving threats. Too much information is overlooked simply because you as an analyst may not know how the information is connected. It's difficult to uncover actionable insights, and you as an analyst may then choose to work on only cases that you're confident about, which could lead to missing certain investigations and exposing your organization to risk. The sheer volume, variety, and speed of insights to analyze make it difficult for you to prioritize your work and get to the root cause. This is true for companies of all sizes, not just enterprises. No analyst knows where to start piecing together local context that helps him quickly and effectively identify the problem at hand. Sometimes you become overwhelmed with repetitive work and fatigue, which results in a breakdown of this process and a high probability of an incident exposing the organization to risk. So how do security professionals know they're successful in protecting and defending their data? There are multiple metrics that you can use, but one that is quite popular and often used is dwell time. Dwell time is basically the duration a threat actor has undetected access in the network until it's completely removed. Whenever we talk to security analysts, the most commonly used words they use to describe their job is overworked and understaffed and overwhelmed. Tier 1 analysts are often new to the industry and to the workforce. It takes time for them to truly develop the skills, confidence, and maturity in your investigation skills. Most analysts have to deal with a plethora of insight sources and may be getting an alert from multiple sources at any given time. Regardless of where the alert is coming from, you as an analyst need to quickly understand the context of a potential threat and correlate trends between different sources, unusual domains, IPs. Jude went through a lot of these during his SIEM overview. You must stay up to date on cyber attacks against specific business industries and geographies and use external research as you learned about in Module 1 of this course. You must prioritize and validate potential malicious activity that could have severe business impact. You must understand expected system behavior to recognize divergent and actual system behavior, report valid threats to appropriate teams for remediation and share knowledge with other analysts, and most importantly, you as an analyst have to provide reliable information to build personal reputation. This process, as you can imagine, is extremely time-consuming, but there's got to be an easier way. The main takeaway here is that there needs to be a partnership between analysts and their technology. They are not mutually exclusive. Each has strengths such as common sense with humans and bias elimination and trade-off analytics with AI, but together as a team, they can better stop threats and reduce dwell times. Also, you as a security analyst play a key role here as well. Remember, AI learns your environment and provides actionable intelligence based on the data that you feed it. So if you're not feeding AI reliable data, you more than likely won't trust the decisions being made for you by AI. In this video, you will learn to understand the features and functions of an industry example, QRadar Advisor with Watson. QRadar Advisor empowers security analysts to drive consistent investigations and make quicker and more decisive incident escalations, resulting in reduced dwell times and increased analyst efficiency. We need to look at the benefits of QRadar Advisor. It won't waste human capital on routine analysis. Instead, automate your repetitive SOC tests and better focus your analysts on more important elements of the investigation and increase analyst efficiency. It'll drive consistent and deeper investigations, whether it's 4 p.m. on a Friday or 10 a.m. on a Monday. Advisor augments human intelligence that you as an analyst are driving consistent and thorough investigations each and every time. It helps to reduce dwell times with a quicker and more decisive escalation process. It determines root cause analysis and drives next steps with confidence by mapping the attack to the MITRE attack model. When investigating an incident, QRadar Advisor first gathers greater context about that incident by mining local data available in QRadar. It then consults with Watson for Cybersecurity to perform external knowledge and threat discovery on discrete observation it has made about the incident. It delivers it via the IBM Security App Exchange powered by Watson for Cybersecurity to provide a quick-to-deploy, easily consumable solution that will transform security operations. QRadar Advisor with Watson unlocks a tremendous amount of security knowledge, enabling rapid and comprehensive investigation insights. QRadar Advisor with Watson looks at structured data, critical security unstructured data, security-related data on the internet. Then it removes unnecessary information and extracts and annotates collected data. Next, it aligns incidents to the attack chain. Through step 1, confidence level for each progression validates the threat, and step 2, visualize how the attack has occurred and is progressing, and step 3 will uncover what tactics can still possibly occur. QRadar Advisor will automatically link investigations through connected observables. It'll avoid duplication of effort, extend your investigation beyond the current offense, and it will also determine if you need to do additional tuning in the case of multiple duplicate investigations triggered by the same event. Through analysis of the local environment, Advisor recommends which new investigations should be escalated to assist you as an analyst. Based on best practices, configuration and assessments, QRadar Assistant quickly scans your local environment and determines if you are ready to take a full advantage of Advisor with Watson. You will now have the opportunity to complete a virtual lab to apply the information you have learned about artificial intelligence and a SIEM.